Hello psychology folks, and welcome to our video lecture. For some of you, this may be the first video lecture that you have attended, and if that's the case, then I'll say sorry for the bad quality of my webcam. It's probably about 5-6 years old, and also I have the quality setting pretty low, so we don't have problems recording the video feed. Hopefully that won't be an issue because you get to see my lovely face in class, so shouldn't be a problem there. So happy Thursday, or possibly Friday, depending on which class you have, or potentially Saturday if you put off watching this a day or two. It might even be Sunday, could possibly be Monday, and if this is Tuesday, it's because you completely forgot and I reminded you in class and now you're playing catch-up. A couple of notes. The way we take attendance in our video lectures is I ask you to click reply in this in the discussion box, and at the end of the video lecture, or possibly somewhere in the middle of the video lecture, I'll ask you a question and ask you to click reply and type the answer to that question. That way you will register your attendance and indicate you have watched the video lecture. And there'll also be a paragraph assignment that you don't want to miss. So again, I hope everybody has had a good week. And today we are talking about, actually I'm trying to recall, what is it that we're talking about? We are talking about memory. Yeah, that was cute, I know. Memory is defined as the retention of information or experience over time. The retention of information and experience over time. Okay, now everybody, quickly. Tell me what memory is. Do you remember? Can you repeat what I just told you memory was? I can. It's the retention of, and right there, I start to go blank and it starts to fade, which is interesting because I'm pretty sure I know this. But it's like it only lasts for a few seconds, and that's one of the interesting things about memory. If you are still struggling to remember what it is the retention of information and experience over time. That's memory. The other thing that you need to know is for this video lecture, we're going to do some exercises that are going to require you to have some sheets of paper and a pencil or a pen, and nothing you're going to have to turn in, so you're on the honor system that you're actually going to do this, though I have no doubt that all of you will do that. So take a minute, go ahead and pause the video if you need to, and get a few sheets of paper or a notebook and a pencil or a pen so that you can participate in some of the memory exercises we're going to do as we talk about memory. I think you'll actually enjoy them, so I think it's something that you're really going to want to do. So go ahead and pause the video and do that. Alright, so you're back, and I am back, and we are going to talk a little bit about memory. Again, do you remember what memory is? It's the retention of information or experience. And now that's important, those two things. Information that you are taking in, maybe studying, you're retaining, or at least trying to retain information right now because you're listening to what I'm saying and hopefully trying to remember some of it. But also, memory involves experience. Things that are happening to you, things that you see, you hear, you feel, you touch, those things are also coming into your memory and can be just as important as, and sometimes stronger than, information like the words I'm speaking that you're trying to remember. When we talk about memory, we are talking about three processes. You are talking about encoding, which is taking in information; storage, which is retaining that information in a mental storehouse. Think about a warehouse in your brain; and then retrieval, which is bringing it back. And actually for a lot of us, it's the encoding and the storage is not quite as big of a problem as the retrieving and the bringing it back. But Encoding, when you think about some of the discussions we've had about the brain and about how you take in information, as we've said, particularly when we're talking about the nerve structure, the physical aspects of the central nervous system, everything that comes into your brain, whether it's the words I'm saying, sounds, sight, smells, it's all being translated into data by your nerve cells. So what I'm speaking to you right now, the words, you're hearing your speaker on your computer, creating vibrations in the air, which are going to your ears, which are triggering the nerves in the little sections of your ears that the eardrum that picks up sound. That those vibrations in your eardrums are translated into electrical signals, which your brain then interprets as speech and then understands the speech. You remember those sections of the brain we talked about that are involved in understanding speech? And then at that point, that information that has been encoded, you think about code, it's been turned into a digital code, kind of like a computer, a storage system. That encoded information is then stored. It's recorded in a mental storehouse. And it's pretty amazing when you think about it, because your brain does not have a computer chip made out of silicone. Your brain has nerve cells and nerve cell networks. And in those nerve cell networks, that encoded information that's coming in right now through your ears is being stored, like a computer hard drive, which is pretty amazing when you think about it. You think about everything that you retain. And then as that information sits in that hard drive, and there are more than one drive, we'll talk about that soon, at some point you may have the need to retrieve it. Let's say, for example, you wanted to repeat what I said 2 minutes ago. You probably can't, at least not word for word, but if you could, you would be going back into your memory, you would be taking that information, retrieving it, and then converting that data that's recorded into the kind of muscle movements required to make sound, and then you would say that. So if I were to say, think about the famous wedding scene, and if I were to say, repeat after me, I, Bob, take Cindy to be my lawful wedded wife, your brain has encoded what I've said, stored it, and then in that few seconds taken and retrieved that information from the storage and re-encoded it back into the muscle movements and the vocal cord movements to make speech. And so in a simple wedding ceremony, you've got all those three processes: encoding, storing, and retrieving. And how many times have you seen a groom who has trouble repeating after me, messing up the wedding vows because maybe something's interfering with the encoding? But that is your basic three processes of memory. Now, encoding, as we just talked about, the groom sitting there listening to the minister or the person administering the wedding saying, repeat after me. Encoding requires attention. And we have different types of attention. We have selective attention, which is focusing on a specific aspect of experience while ignoring others. Depending on where you are watching this video lecture, you may be employing selective attention right now. If you're sitting in a room with a bunch of kids and they're playing video games or running around or making all kinds of noise, you are probably trying to selectively focus your attention on this video and trying to exclude and not focus your attention on that noise. If you're sitting in a coffee shop or a restaurant or maybe in the middle of a field, you're trying to focus your attention on what I'm saying, I hope, and less attention on the things around you that could be distracting. Divided attention means that you're trying to concentrate on more than one activity at a time. Now, I would certainly hope that you are not trying to watch this video lecture on your smartphone while you drive. That would be extremely unsafe. I hope you're not doing that. What is more likely is that you are watching this video lecture on your laptop while perhaps at the same time watching TV. or playing a video game, or sitting with your friends and engaging in a conversation, or maybe you're eating a sandwich and you're dividing your attention between what I'm saying and these other things that you're doing. That's divided attention. Sustained attention, sustained meaning a long period of time, is the ability to maintain attention to a selected stimulus for a prolonged period of time. If, for example, you're able to sit in my class and listen to everything I say and keep all of the other distractions away for an hour or an hour and 15 minutes, you are capable of sustained attention in my class. Now, to be, let's just be honest, I don't expect you to be able to do that. One, I'm probably not that compelling a speaker, and two, that's unrealistic. But the more you're able to maintain attention on one thing for a prolonged period of time indicates your ability to sustain your attention. Here is a model of how memory works. This is the Atkinson-Shiffrin memory model. Say that 5 times fast, or try to remember it. Here you have your sensory input. In this case, it's the words that I'm saying and the images that you're seeing, which goes into your sensory memory. We'll talk about sensory memory in a minute. That sensory memory is encoded. Remember, sensory, we're talking about hearing, touch, taste, feel, smell. That's encoded into your short-term memory. Now, the short-term memory is interesting because it involves something called rehearsal. Have you ever tried to keep? Have you ever tried to save somebody's phone number? Let's say somebody gives you a phone number. You're in a restaurant or a bar, and somebody says, you say, "Can I have your phone number?" And they say yes, or they want to give you the phone number, and you have nothing to write with. You can't write it on your hand, and you're going to get to something, but they give you the number, the 7 digits. Let's say it's 912-5431, and the way you keep it in your memory is by repeating it over and over again. 9123. See, I've already forgotten it, but you repeat the number over and over and over again to keep it alive in your memory, so that eventually you can get somewhere and write it. And what you're doing is you've almost created this, as it shows here, this rehearsal loop, because as that number sits in your short-term memory, when you speak it out loud, you're re-encoding it back into your memory and speaking it and re-encoding it. Sometimes you're not speaking it out loud, you're saying it out loud to yourself in your head, and you're trying to keep that thing alive in short-term memory. And you can do that for a while until you get distracted. That short-term memory will then be transferred or encoded into long-term memory, where it will stay for a while, hopefully for a long while, and from which you can retrieve it back into short-term memory and use it. So if you're lucky, for example, passwords are a great example. When you set up a new internet account and you've got a password, and you often have to write it down, eventually you will store that password in your long-term memory and you'll be able to retrieve it. Your PIN number for your ATM card is a good example. When you first get that ATM card, the PIN number is in short-term memory, but you probably have it written down somewhere. But eventually, if you use it long enough, that's going to be encoded and transferred into long-term memory, and you'll be able to pull that PIN number up from that long-term memory anytime that you need to. So this is the Atkinson-Shiffrin model of memory. As we said, encoding requires attention. Divided attention, concentrating on more than one activity at a time. Divided attention can be detrimental to memory encoding. So if you're watching this video and doing something else, eating, playing a video game, maybe you've got a football game on, that could be detrimental to you remembering what I'm talking about. And this gets to the concept of multitasking. You hear a lot about multitasking. A lot of people think they're really, really good at multitasking. They think that multitasking is something that is desirable. I can talk to you, and I can listen to music, and I can be working on my smartphone, doing email, and a whole bunch of other things. But many psychologists believe that multitasking is, in fact, a myth. There's a motivational speaker, a guy named Dave Crenshaw, that does a video that includes a multitasking test. And so now is the time to get your sheet of paper. We're going to show a video here in a second, and you'll need that sheet of paper to do this multitasking test. And so follow what my friend Dave Crenshaw says in this upcoming video, and we'll see how good you actually are at multitasking. Well, it is truly amazing what can happen in the space of just a few seconds. In the time since I recorded the last segment of this video, my laptop computer crashed, and then crashed again, and then crashed again. So we have moved, and I am now finishing up this video in another location, my home office. So I have the nice microphone set up here because that's the only microphone I have on my home computer. So hopefully this will continue to work. I know it looks like I'm going to sing to you, but don't worry, I'm not. Won't put you through that. So let's get back to where we were, and I think as I mentioned, have your piece of paper ready. We're about to watch a video by Dave Crenshaw, and it may take me a little bit to get the audio working since we're running a little bit different setup. But use the piece of paper that you have in front of you. You don't have to download anything, and try Dave's multitasking test. Here we go.
In my book, The Myth of Multitasking, How Doing It All Gets Nothing Done, and in my keynote speeches, I share with people an exercise. Call it the multitasking exercise. Now, I've never done that exercise in a video before, so you and I are going to do it together right now. On this page somewhere, you should see a link to a PDF file. Click on that link, download the file, and print it out. Go ahead and pause the video if you need to. If you can't find the link for some reason or it's going to take you too long, just get a piece of white paper, turn it horizontal, and draw 3 horizontal lines across the paper. That's really all you need. Now, I'm going to give you the instructions for this exercise, but don't start until I say go. You are going to recopy the phrase, multitasking is worse than a lie. Mark Twain is credited with saying, there are lies, damned lies, and statistics. I like to change that a little bit and say, there are lies, damned lies, and multitasking. Why? Because so many people persist in multitasking, thinking it's a good thing, despite the overwhelming scientific and real-world evidence that it's counterproductive and, in fact, sometimes dangerous. So you're going to experience that firsthand. You're going to recopy the phrase, multitasking is worse than a lie, and you're going to write the numbers 1 through 27. One number for every letter in the phrase. All right, get your pen or pencil out, and I'm going to start you. Ready, set, and go. 5 seconds. 10 seconds. 15 seconds. 20. 25 seconds. 30. We'll go 10 more. 35. And 40. Okay, just write down the time at which you approximately finished, just off to the side. Now we're going to do this exercise again, but this time you're going to multitask or switch task. So what you're going to do is for every letter that you write, you're going to write a number. M1, U2, L3. This is a pretty good example of what happens in your day when you think you're multitasking. What you're really doing is switch tasking. You're switching back and forth rapidly between these different tasks, and you're going to experience what happens. So go ahead and grab a pen or pencil, and I'm going to time you again. So ready, get set, and go. 5 seconds. 10 seconds. 15. 20. 25. 30 seconds. 35. 40 seconds. This is where we were when we stopped last time. 45 seconds. 50. We'll go 20 more. 55 seconds. 60 seconds. 65 seconds. And 70. Stop there, and if you didn't finish by now, just give up. You experienced in this little exercise firsthand the 3 consequences of multitasking. Number 1, things take longer when you multitask. Number 2, the amount of mistakes you make increase. How many of you ended up on a number different than 27, even though you already knew what number you were going to end up at? Number 3, for most of you, your stress levels increased. So I'd love to hear your perspective about this exercise. Go ahead and write that down on this page. Ask me any questions you'd like. I look forward to talking with you.
So what do you think? Do you still think multitasking exists? Are you able to multitask, or is it just a myth where you are just shifting your consciousness or your focus from one thing to the other really quickly, and you're not actually focusing on both things at once? People who drive and text, you might get the sense that, or they might tell you, well, I'm multitasking, I can watch the road and text at the same time. If you've ever actually done it, and it is against the law, and you've been texting and suddenly your focus suddenly gets on the cell phone for just a little longer than you intended, and you look up and the guy in front of you stopped and you have to slam on your brakes, then you may have a better sense of how multitasking isn't really multitasking, it's switch tasking. So good exercise there. Don't text and drive, or actually just talking on the phone can be just as bad as texting, because your focus goes to the conversation, which is internal, inside your head, and not externally to what's going on out in the road. So talking on the phone at all while you're driving is switch tasking. All right, memory. Levels of processing. Let me get out of the way here. There are different levels of processing when it comes to remembering things. There is shallow processing, intermediate processing, and deep processing. So shallow processing is here. I show you these 3 letters, and your brain processes the fact that there are the shapes and letters of a word here, a D and an O and a G. And that's all you process. That's very shallow. Intermediate processing is you look at those 3 letters, put them together, and you say, oh, that spells dog. The old, electric company, where you'd go og, dog. That's what that word says. That's intermediate processing. Deep processing is you actually look at that, say the letters go together, they spell dog, and I know what a dog is. A dog is an animal, a dog is a pet, and particularly if you think about, if you have a pet dog, you think about your pet dog. That's called deep processing of memory. So shallow processing, you remember that there are letters, and you remember the shapes of the letters. Intermediate, you actually put them together in a word, and deep, you think of the meaning. So you see how we're going deeper and deeper into the thought process here. And then the imagery, when you go really, really deep, okay, everybody say, oh, look at the cute puppy, is when you go even deeper into processing of the memory. So in this case, you've not only looked at the letters that were on the page and put them together to make the word dog, D-O-G, and then actually thought what a dog is, then you connect it to an image. Maybe this is your puppy at home, and you connect it to that image, and that's one of the most powerful ways to make the memory. As you might have already assumed, if you're trying to remember something, the deeper the level of processing, the more likely you are to remember it. Here's a good model of working memory, which shows you, again, how this works. You have your input that goes into sensory memory, And sensory memory is that memory that of all the things that are coming in all at once, and all the things I hear, all the things I see that I'm maybe not necessarily focusing on. It goes into that big sensory memory bank, but that all decays very quickly. We'll choose what in that sensory memory we want to focus our attention on, and the central executive focuses on three different areas of the memory in our brain. Three things called the visuospatial scratch pad or sketch pad, the phonological loop, which has an auditory control, and then long-term memory. So the central executive part of your brain takes this information coming in, and for example, let's say I ask you to remember my dog is a bright yellow lab. Two things are going to happen. You're going to think about that. You're going to think about a picture of a bright yellow lab. That's going to go into your visuospatial sketch pad. So your brain will conjure up a mental image. That's another name for the mental image. And then the phonological loop in your short-term memory is going to be repeating over and over again, my dog is a yellow lab, my dog is a yellow lab, or a bright yellow lab. See, now even I can't remember. And so between those two, you'll have that stored in your short-term memory. If you can repeat this long enough, the central executive will eventually store that in the long-term memory. So that's a diagram of how this works. So let's talk about those types of memories. According to the Atkinson-Shiffrin theory, sensory memory, that memory that comes flooding into your brain from everything that's coming into you through your eyes and ears and nose, that lasts anywhere from a fraction of a second to several seconds. And again, this is unfiltered input. This is everything coming in. Your brain just kind of takes these ongoing snapshots of everything coming in around you, and it saves it all, and it's a lot, but it doesn't save it for very long, because you might imagine it takes a lot of storage space to store all that information, and your brain can't store that for long periods of time because of how much space it will take. And so all that information is stored for a fraction to several seconds. Again, I think we talked about this in class. If you're walking through a crowd and I would ask you to tell me about the people who you just walked by, if you didn't really know any of them, that's all sensory memory, and that's going to be gone pretty quickly. Now, short-term memory, when you focus your attention on something coming in through those senses, through that sensory memory, and you focus and it goes into short-term memory, for example, me asking you to remember about my bright yellow lab dog or other things, you have limited capacity, about 30 seconds or so is how long things will stay in your short-term memory, unless you can repeat it. You remember we talked about how you might repeat something over and over again. That keeps feeding it back into your short-term memory, and as long as you can repeat it, you can extend that a little beyond the 30 seconds. But otherwise, if I were just to give you a phone number and ask you to remember it, and you didn't repeat it to yourself over and over again, you just tried to keep it in your memory, 30 seconds is about all that it would last. Now, if you can get that phone number into your long-term memory is permanent, and this is interesting, nearly unlimited capacity. Nearly unlimited capacity for long-term memory. Pretty amazing when you think about it. Sensory memory, just going back into some detail, a fraction of a second to several seconds. It's very rich and detailed. You actually process more than you consciously notice. People who have that photographic memory are able to actually tap into some of that stored sensory memory. And there are two types of memories. Echoic memory, which is a memory for sounds, which you're remembering right now as I'm speaking to you, and iconic memory, which is the memory for images. Echoic, think echo, and then images, think icons, like the icons on a computer. Images, echo, sounds, icons, images. Short-term memory, limited capacity, 30 seconds. George Miller's magic number for short-term memory was 7 items. Here's George Miller in an article in the New York Times back in 2012. when he died at the age of 92. And in this article, he is accredited for going against behaviorism, which, as you might recall, behaviorism indicated that everything happened externally. There was no conscious mind work going on. Miller was able to show that the human mind, even though you couldn't actually see the mind, you could observe and test the mind working. When it comes to memory, Miller's famous formula is the number of things, of individual items you can store in your short-term memory is 7 plus or minus 2. So some of you may be able to store 9, some of you may be able to store 5, but typically if I were to ask you, and I'm going to ask you in a minute, to remember a sequence of things, of numbers or objects, more than likely you'll be able to remember a total of anywhere from 5 to 9. That's the limit. Now it's interesting because if you're remembering numbers, that that would be the phonological loop, where let's say I gave you a 7-digit phone number and you tried to remember it over and over again, and I also gave you some pictures to remember. The phonological loop, that those words that you repeat and you keep in that short-term memory, and the visuospatial sketchpad, your memory for images in the short term, are completely separate. They're two separate hard drives. So you can memorize numbers in one and still memorize images in the other. It's just a nice little tip for remembering. If you're having trouble remembering things, if your brain is full, if you ever felt that way, that your brain is full and you're having trouble remembering something, remember it as a picture, and you'll tap into a completely fresh hard drive in your brain to remember things. So we're going to measure your short-term memory. This is a test that was created by the faculty at Washington University, and we're going to start. Go ahead and take on your sheet of paper, and number 6 lines. And with each line, you're going to write down what you remember. How this works is you're going to flash letters on the screen, and then as soon as the letters go off the screen, write down as many of the letters as you can remember, and we'll see how well you do. So I'm going to get out of the way, and I'm going to increase the size here so you can see it well enough. There we go. Alright, so get ready, and again, don't start writing until the letters go off the screen, and then write all the letters you remember. So here we go, here's the start. Alright, write down everything you remember. Let me make that a little bit bigger. Okay, ready? Here we go with the next set. And now, write down all the letters you remember. Give you a minute to do that. Okay. Here we go with the next group, group 3. All right, here we go. On the honor system, write down all the letters that you remember. Give you a few more seconds, and then we'll do the next one. All right, here we go. Ready for the next test? Get ready. All right, a little tougher there, so go ahead and write down all the ones you can remember. I'll give you a little bit more time. Are we ready for trial 5? Here we go. All right, write them down. There's one more group left. All right, ready for the last trial, and here it comes. was quick, wasn't it? That was actually faster than I expected. See how you did. Write down what you can remember. Um, yeah, this asks some interesting questions. Were there patterns? Did you remember first letters, last letters? What I'm kind of primarily curious about is how many letters were you able to remember? Did you find that the 7 plus or minus 2 was accurate? Were you able to remember as many as 9 letters? Did you start coming up having trouble after remembering more than 5? I'll be curious in class to talk about how you did. In fact, I think that'll be our reply a reply answer to this video when the video's done. And I'll remind you again at the end of the video. Click reply and talk about how you did on the number on remembering the letters, and whether or not you were actually able to remember more than 9 letters or maybe less than 7. And if you did remember more than 9, how you did it. That would be really interesting to see. Now, Miller's 7 plus or minus 2 concept does have some limits, as you can see in this article from the New York Times. Remembering 7 words like cat and ball and dog and bark. It's a little more easier than remembering 7 long words such as onomatopoeia. Anybody know what onomatopoeia means? Anyone? I do. Or reciprocate. So if you're using very large complex words, you're probably not going to be able to remember as many as if you're using small words. But one way that you can get past that 7 to 9 to 5 limit is by something called chunking. It's good to know that our brilliant psychologists can come up with very fancy words for complex memory techniques like chunking. But that means about what you would expect. You remember things in chunks instead of in very specific things. Actually, and some of you may have done this too. In the letter memorization exercise that we did, there was one group of letters where the last 4 letters, and see, I even still remember this, was M-A-U-X. And so instead of trying to remember M-A-U-X, I remembered the letters that came before that, and I remembered that as MOX. I remembered it as what it sounded like, and see, I still remember it. But what I was able to do, instead of remembering 4 letters and taking up space in my memory bank, I was just remembering one chunk, and that one chunk I was able to then pull back apart when it came time to write those letters out and write out M-A-U-X because I remembered them as a chunk, as MOX. Here's another example of chunking. So let's say I ask you to remember these letters. So look at them for a few minutes, and then we'll see if you can remember them back. Okay, so how many of those letters can you write down right now? Just give it a shot. Let's take just a few seconds and let's see how long it takes you to write down what you can remember. If I had the Jeopardy music, I'd play it. I'll try to find the Jeopardy music. Maybe I'll play it on the next one. But I'm guessing that you're probably sort of running out of memory space, and chances are, well, if you're like me, you didn't remember a lot. Here, let's go back for a second. That's what they are. Now, some of you may be smart enough to have already figured this out. Let's say we take these letters and we put them in different kind of chunks, because these are chunks, but it's kind of hard to LDAN. It's kind of hard to remember those. What if we chunked them up this way? Now look at the chunks, and for just a few seconds, and now if I were to ask you to write down and remember, here, ignore this. If I were to ask you to write down and remember all the letters that I just put on the screen, you'd be able to remember them all, because you're remembering them in chunks, Old Harold and Young Ben, And also think about the level at which you're processing. You're not just looking at shapes of words. Now you're looking at shapes of words turning into, or shapes of letters turning into words, and you're processing what these words mean. Old, Harold, a man. You may know someone named Harold, and the conjunction. So you've processed really deep, and because of that deep processing, my guess is you probably were able to remember every single one of those letters when you wrote them down. And here's another example of memory chunking. So we're going to do this demonstration. I'm going to show you a list of words. Look at them for 2 minutes and try to memorize. Don't write anything down, but try to memorize as many words as you can over those 2 minutes, and then we'll write them down. So let me get my stopwatch going, and here we go. Really do need the Jeopardy music. Maybe I can find some. There we go. Got about a minute left. Keep looking. Try to remember as many as you can. Cram those words into your brain. Isn't that nice? About 30 more seconds. Alright, that is 2 minutes. And now, let's see, on your piece of paper, how many of those words can you write down? Go for it. Write down as many as you can. Here, you want to hear the Jeopardy music again? Alright, yeah, I think that's enough of that. Alright, we'll stop the Jeopardy music. Alright, so if I'm going to go ahead and move on. If you're still writing down words, go ahead and pause the video and then finish writing down, and let's see how many you get. How many did you get? Did you get more than 7? If you did, I'm curious as to how you did that. Was there visualization involved? Did you think about pictures as well as words? Now, I mentioned that according to Miller, the typical storage capacity 7 plus or minus 2. Let's try the same thing that you just did with these words. Again, we'll do 2 minutes, and then write down all the words you can remember. Here we go. Try to remember. Maybe try images and not just words. Think of pictures. One more minute left. In case you're wondering, if we weren't doing a video lecture, this is exactly what we'd be doing in class. Listening to music and looking at these words. Almost done. Alright, that is about 2 minutes. So, write down all the words you can remember. I won't play the music anymore. Just write down all the ones you can remember. It'd be interesting to see how far past 7 that you're able to go in this group. And it's possible you may do much better in this group. I'm going to move on, so if you're still writing, pause the video and then resume the video when you're done writing. If you'll notice, these words are much more easily chunked than the previous group. There's the previous group. These are just random. These words have similar categories. You've got animals, colors, furniture, school things, fruit. And so if you were thinking in chunks, thinking of this chunk of animals, chunk of colors, chunk of furniture, chances are you were able to remember more words by using that chunking technique. You may consider using this in studying if you've got tests where you're trying to just raw memory, remember lists of things. This may be helpful to you. And particular chunking works particularly well if you can, for example, make a story out of it. So if you were to sort of think of yourself, I went to the petting zoo and I pet a horse, a cat, a dog, a fish, not sure how you pet a fish, but I think it's possible, and a bird. And then maybe I went out to the garden and I saw flowers that were orange, yellow, blue. You could imagine in this situation, imagine a room with a table, a chair, a desk, a bookcase, and a bed. So if you put a story to those chunks, you can remember even more. Again, we're talking deep processing. Or, and we do this a lot, you create a word out of the first letters. So this would be O-Y-B-G. Well, that's not a word, but if you created something, an alliteration where you created a sentence that had an H, a C, a D, an F, and a B. See, can I do this on short notice? How come dogs fight birds? And then maybe that could lead you to remember them better, or maybe you could just make a story out of those about the horse and the cat saw the dog and the fish, and they all chased a bird. That's getting silly, but you get the idea. Rehearsal. When it comes to memory, rehearsal is mechanically repeating information without any meaning. And so rehearsal is just sitting there thinking horse, cat, dog, fish, bird, horse, cat, dog, fish, bird, horse, cat, dog, fish, bird, saying it over and over again, hoping you remember. When you rehearse it with meaning, when you tell yourself a story, you're much more likely to remember it. So congratulations, you have survived to the end. We've all survived to the end of this video lecture. Hope it was interesting, maybe enjoyable. And here's the last thing that you need to do. Told you there'd be a question, and this is how we can tell who has attended the video lecture, so I can give you credit for attendance. In this what's the word I'm looking for? In the box that you're looking at, in the discussion box, you should see an option to click reply. So click reply, and tell us how many numbers you were able to remember in the first memory exercise, and maybe how many words you were able to remember in the second exercise. Were you able to remember more than 7? Was it less than 7? Was it exactly 7? If you were able to remember more than 7, 9, maybe even more than 9, tell us how you did it, because I'd like to find out too, because 5 to 7 is pretty much my max. All right, great. Hope you have an excellent weekend, and we'll see you in the next class.